So in the previous videos, we learned about speed and velocity, distance and displacement. So in this video, we will learn about a more advanced topic, which is graphs of motion. This is a very important topic. It will help you in understanding the concepts of motion very clearly, and it will help you a lot in future exams. Okay, so let's move on to the actual content. Now, this is a graph. As you can see, we have a y-axis and we have an x-axis. On the y-axis, we have distance, and on the x-axis, we have time. So this is an empty graph. It doesn't have any content, but this is, I wanted to show how a graph looks like. So in majority of the cases, we have distance or any other quantity which is against time on the y-axis and time on the x-axis. Okay, so yeah, time always go on the bottom x-axis and the distance goes up the side, the y-axis. So if it's a distance time graph, distance will go on the y-axis and the time will go on the x-axis. If let's say if it's a velocity time, acceleration time, or whatever against time, the time will go on x-axis and the other quantity will go on the y-axis. Okay, so this never changes. So make it a habit to write time on the x-axis and another quantity on y-axis. Basically, a quantity which is changing with respect to something, that something will go on the x-axis and the quantity which is changing will go on y-axis. So yeah, this might change from question to question but while you're solving your question, you should make a habit to put time on x-axis. If the question is given, but if the question is giving you x-axis as some other quantity, then it's a different question altogether. Okay, so keep that in mind. Now there are multiple graphs, so we'll not be able to talk about all the types of graph, but we'll try to talk of most of them. So all the graphs. But we'll try to talk about most of them, and the remaining ones we'll try to cover in the upcoming videos. Okay. So the case one is when the object is at rest. Okay. So when the object is at rest, what does it mean? When the object is at rest, the distance is not changing, right? The object is not moving, so the distance is not changing. The distance is not changing, but the time is changing. So if we draw a graph, okay, this is y-axis and this is x-axis. So the time, as we talked in the previous page, time will come on the x-axis and the distance will come on the y-axis, right? Now the distance is not changing, which means the distance is on y-axis. So the quantity on y-axis is not changing. So there cannot be any movement on y-axis, right? We cannot go up or down on this direction in this direction, but time is always changing, right? You cannot stop time. So time is moving in this direction. So what is the possible graph? I see only one graph is possible in this scenario, that nothing is moving up, but you're moving in this direction. So a straight horizontal line is only possible graph when the object is at rest. Okay, a flat line. The distance is not changing. So hence there should be no movement on the distance axis, which is y-axis. And since the time is passing, there will be movement on the time axis, which is the x-axis. Hence only straight horizontal line is possible. So this is the case where an object is at rest. This is the most basic, simplest case. So, but it will help to build your understanding in the right direction. Now, object can be at rest. What can be the second option? The object is moving, but at a uniform speed, at a constant speed. Okay, so what will be the graph? Think about it. Okay, so we'll move on to next case, uniform speed. So what does uniform speed means? Basically, it's a constant speed, right? And in the previous lecture, what we learned about speed, speed is basically distance over time, how much distance you travel and in how much time. So basically, in same intervals of time, you are traveling same distance, which means the speed is constant. Now, if we draw a graph of distance in time, this is a graph, okay? So this distance is on y-axis and the time is on x-axis, all right? So, okay, you might have learned this in basic maths, but if not, we'll learn it today. So, in a graph, the most important thing is slope. Not the most, but one of the most important things is the slope and then the intercepts. So here we'll talk about slope. So slope is basically y-axis divided by x-axis between any two points. So and the division is basically the slope. which means how fast this line is moving up. That is the slope of this graph, right? Which is y by x. How much time did y took in moving from this point to this point, or from this point to this point, any two points. So we'll talk about, but in particularly in this case, since this is straight slant line or constant speed, in this case, in between any 2 points, the slope will be same. Okay, so it doesn't matter in this case. So basically, the slope is y by x. So y by x is what? Distance over time. So distance over time is what? Speed. So the slope of this graph will tell us the speed. Okay. Now, if you let's say you come at this point and let's say this is y and this is x. So if you do y by x, it will give you a slope, and that value will be same as if you do slope on this y by x point. Okay, so this is a straight line. So we need to make sure that it's a straight line so that the slope is constant. Slope is constant means distance over time is constant, which means the speed is constant. Okay, so this is what I've written over here. Uniform speed means constant speed. Constant speed means distance over time is constant because the speed equal to distance over time. And distance over time is basically y by x of this distance time graph. So which means that the slope of the distance time graph has to be constant. So the slope has to be constant means, okay, one more thing. Slope can be constant if it's a straight line, straight horizontal line, but in that case, the object will be at rest. In our case, in this case, the object is not at rest, but it's moving with a uniform speed. So that graph, the possibility of that graph is not there. So we are left with only this possibility. Okay, but yeah, the graph can start from here also, or from any point, but the slope has to be constant. If it's starting from this point, which it means that the object was at origin or was at zero, or whatever whatever base we are taking, okay, for measurement. So yeah, but the key point is that it will be a straight slant line because the object is moving but in a uniform speed. So the slope has to be constant and it has to cover some distance. Okay, so this is a point to be noted, that the slope of the distance time graph is the speed. And you learned from this uh, topic is that the slope of a graph is y by x. Okay, it will help you in future graphs. So basically, this is the concept which will help you in upcoming topics. Okay, so the steeper the line, the faster moving object, because steeper the line means slope is more. You're covering more distance in the same amount of time. So the steeper the line, more slope. More slope means distance over time is more, which means the speed is more. So the object is moving faster, right? Okay, so these are the two cases we discussed. Now, what can be a third case? So the first case was the object is at rest. The second case here is that the object is moving but at a constant speed. Now, what can be a third case? Object is moving but not at a constant speed, right? So the third case is, let's say this curve is a straight slant line, but what if this curve goes up like this? It's this uh, it's getting steeper. What curve, right? Okay, so let's go to that. What does that mean, and how do we get information from that graph? Okay, so this is the graph which I talked about. This is the case 3. So this is a distance time graph, and the curve is going steeper. Now, what does that mean? So we learned that the slope of distance time graph is speed, right? So how do we calculate the slope? We calculate the slope based on y by x, right? But the y by x in the previous slide was constant. So we could measure y by x, we could measure slope. But in this case, the y by x of every point is different. So you learn this later in integration differentiation. How do we calculate the slope at an instantaneous point? But I'll tell you is, if the graph is going this way, right, in the vertical direction, if it's getting steeper from kind of horizontal towards asymptotic towards vertical, it means that the slope is increasing. Like it's covering more distance in lesser time. Here in this, it will cover same distance in more time. So the slope is increasing. Basically, the speed is increasing. And what does that mean if the speed is increasing? If the speed is increasing, is that the final speed is the final speed is more than the initial speed, which means that v minus u is greater than 0, which means that, okay, it's an acceleration. We learned about acceleration in the previous video. What is acceleration? Acceleration is a change of velocity over time. If there is a change of velocity, there has to be acceleration. And if it's positive, it's a positive acceleration. If it's negative, it's a negative acceleration. Okay, acceleration. So keep in mind, how does the graph of acceleration look like? So the graph of acceleration, sorry, the distance time graph of acceleration looks like this. It will be a curve getting steeper. Okay. So basically, just from the shape of the distance time graph, you can know what motion it is. No calculation has to be done. If you are given a distance time graph, you can know, okay, if it's a horizontal line, the object is at rest, there is no movement in the distance. If it's a straight slant line, the slope of the distance time graph is constant, which means the speed is constant. Now, if it's a curved graph, it means that the speed is increasing and there is acceleration. Okay. Now, there is one more, there is one thing, and now there is one point to think. Okay. We thought about this graph, but what can be more in distance time graph? If you think, if you can think of any other option, let me know in the comments. So now there is one point to think. We discussed about that the slope is positive, so the acceleration is positive. But what if the acceleration is negative? If the acceleration is negative, how will the graph of distance time look like? Think about it. Okay, and let me know in the comments how will the graph of negative acceleration look like. I think you have pretty good. You should have pretty good understanding from the concepts learned till now. Okay, so these are the distance time graphs. Now let's move on to the velocity time graphs. So it's similar to distance time graph. The only thing changes is the y-axis, the quantity which is changing against time. So in the distance time graph, the quantity is the distance which is changing against time. Time is on x-axis and the distance is on y-axis. Now instead of distance time, here velocity is changing with respect to time. So it's a velocity time graph. The graph is blank. It's just to show the graph. Okay. So the same idea, but velocity on the y-axis. Now, the first case, the same. In the distance time graph, the first case was that the object is at rest. Here, the first case is that the velocity is constant. Okay, so velocity is constant. How should the graph look like? So as we learned in the previous section, constant y-axis means horizontal flat line. So the constant velocity means a horizontal flat line. In the constant distance graph was also a horizontal flat line. Same as that, the constant velocity graph will also be a flat horizontal line. Okay. Now, so we'll not spend much time on this. So we'll move to case two. So case two is velocity. If the velocity is increasing steadily, okay, it's same as the case two of distance time graph, where the distance was increasing steadily, and we called it uniform speed. This is uniform velocity. Now this is velocity increasing steadily. Okay, so as we learned in the case of uniform speed, here the slope of velocity time is constant. Okay, so uniform speed, the speed is increasing uniformly. It means that against time, the slope of velocity time graph should be constant. That's why it's a straight slant line. Now, but what does it signify? So velocity time graph, the slope of velocity time graph should be what? Velocity over time is acceleration, right? The change in velocity over time is acceleration. So the slope is constant. Acceleration has to be constant. So this is a graph of constant acceleration. Okay. This is a graph of constant acceleration. Now, there is one more to think on this graph. We learned about slope. We can get, so the y by x is the slope, and we can get another quantity from the graph. Basically, velocity time graph can tell us about acceleration, because velocity over time is the slope of this graph, and that is acceleration. But what more can we get from the graphs? One thing is slope, okay, but then what can be another thing? Okay, so think about it. Okay, we'll move on to that. Okay, so we learn about this. So slope is a division of y by x axis, but we, what about multiplication? we did division, but what if we multiply y and x-axis? What can that give? So basically, velocity over time can give us acceleration, but what is velocity into time? Velocity into time is what? It's distance, right? So so in this graph, let's say an object traveled from here to here in this much time. So what if we multiply y1 and x1? So at this point, let's say the velocity is y1 and the time is x1. So basically, what we are doing is from this point to this point, the change in velocity is y1 and the change in time is x1. So what if we multiply y1 and x1? We can do that, but we cannot directly multiply it. We have to take area over it. So y area, you learn it in integration, but assume that it's a fact for now that multiplication has to be done by counting the area under the graph. So for multiplication, to get the distance, we have to take the area of this triangle. So basically, this is a straight line. This is a straight line. This is y1. So the this this distance is y1 and this distance is x1, and it's a right angle triangle. So the area of the graph can be uh, calculated as to how we calculate the right angle triangle's area. So basically, it's half into base into perpendicular, half into x1 into y1. Okay. So what will that give us? That will give us distance. So from the same graph, we can calculate two things. One is the slope by division, another is area by multiplication. Okay. So the, and depending on what quantities are on the y and x axis, we can get respective quantities. So in this case, velocity time slope can give us acceleration, and the multiplication area in bracket can give us distance. Okay. Now we'll move on to one example. So let's say we have a velocity time graph and it's a flat line as at 15 meter per second for 8 seconds. What distance is covered? Okay, so how will we solve it? So first we'll create a velocity time graph, right? So this is a velocity time graph. It's a flat line at 15 meter per second. So the y1 value will be 15 for 8 seconds. So x1 value will be 8, right? At for 8 seconds, the line is flat, which is 15 meter per second. Now, what is the distance covered? How can we calculate the distance? We can get two things from the graph, right? One is the slope, velocity over time. What does that give us? That gives us acceleration, but we are being asked distance. So the distance the second thing we can get is the multiplication, right? Velocity into time is the multiplication, and that can give us distance. So it's simple. It becomes a rectangle. So I1 into x1, which is 120. So the distance is 120 meters. So So that's all for this video. We'll we'll meet in next video with more upcoming concepts, more interesting concepts. So for now, let me know the answer in comments of the previous question, and yeah, please like and subscribe, and we'll meet in the next video. Thank you.